Let's do example 2. Determine the general solution of 4 sin x cos x is equal to 2 sin x. Right? Remember that sometimes you may be required to factorize a trigonometric equation in order to solve it. Right? So you have to remember all your factorizations, remember the highest common factor, remember the trinomials, grouping in pairs, difference of two squares. You have to remember those. We can factorize this, but we have to write this in this form first. 4 sin x cos x minus 2 sin x is equal to 0. Right, if we check here, we have the highest common factor. Between this term and this term, we have the highest common factor, which is 2 sin x. We factor it out. So this is 2 sin x. And then we're going to have 2 cos x, then minus 1 is equal to 0. Right? And then it's either 2 sin x is equal to 0 or 2 cos x minus 1 is equal to 0. Therefore, sin x is equal to 0 or cos x is equal to 1 over 2. So now we have sin x is equal to 0 and cos x is equal to 1 over 2. So we have to find the general solutions from this and this. So we're going to start by using the formula method, and then after that we're going to go to the quadrants method. Right, I find the formula method faster, so we're going to start with it, and then after that we do the quadrants method. Method 1, let's call it formula method. For sin x, so what do? We start by finding the reference angle. Remember that. So our reference angle is equal to arc sin x equal to 0. So it's arc sin 0, which is equal to 0 degrees. So our reference angle is 0 degrees. So what do? Remember we talked about this. For sin x is either theta is equal to reference angle plus 360 times k, where k is an integer, or 180 minus reference angle plus 360 times k, where k is an integer. So we're going to use these two. So it's going to be x is equal to 0 degrees, which is our reference angle, plus 360 degrees times k, where k is an integer, or x is equal to 180 degrees minus 0 degrees minus your reference angle, right, plus 360 degrees times k, where k is an integer. Right, you can simplify these two. So we have x is equal to 360 degrees times k, where k is an integer, then or x is equal to 180 degrees plus 360 degrees times k, where k is an integer. Okay, right. Now that is for sin x. So we have this and this. So we have to write all of them at the end. And then we have cos x, this one. For cos x, our reference angle is equal to cos 1 over 2, which is 60 degrees. So our reference angle is 60 degrees. Then we're using this. So it means, therefore, x is equal to, our reference angle is positive or negative 60 degrees plus 360 degrees times k, where k is an integer. We can write these separately. Write them as x is equal to 60 degrees plus 360 degrees times k, where k is an integer, or x is equal to negative 60 degrees plus 360 degrees times k, where k is an integer. So for our general solutions, we have this, and that. Okay, that's when you're using the formula method. That, right? Let's just remember this. As we do our quadrants method. Sin x is equal to 0 and cos x equal to 1 over 2. We just did this part, and then we're going to start here when we're doing the quadrants method. Right, let's say quadrants method. right? Let's start with sine x. 4 sine x, right, is equal to 0. 0 is positive. We take it as positive. So we know that sine x is positive in quadrant 1 and quadrant 2. Right, in quadrant 1, so it's going to be just x is equal to our reference angle plus 360 degrees times k, where k is an integer. Right, and then our reference angle is what? Is 0. Remember, we found that our reference angle is 0 for this one, and then here our reference angle is 60 degrees. So x here is 60 degrees as reference angle, and x here is 0 degrees as reference angle. Okay, right? So it's going to be x equal to 0 plus 360 degrees times k, where k is an integer. Right, so x is equal to 360 degrees times k. Just remember that. And then quadrant 2, right, so it's going to be x is equal to 180 degrees minus reference angle, then plus 360 degrees times k, where k is an integer. Right, so it's going to be x is equal to 180 degrees minus 0 degrees plus 360 degrees times k, where k is an integer. Remember that some steps you can skip when you're doing it on your own. I'm doing all the steps because I'm explaining, so I have to do everything. Right, so x is equal to 180 degrees plus 360 degrees times k, where k is an integer. Now let's do for cos x. Now we say that our reference angle here is equal to 0 degrees. Our reference angle here at cos x is positive in quadrant 1 and quadrant 4. At quadrant 1, this x is equal to our reference angle plus 360 degrees times k, where k is an integer. Right, so our reference angle is 60 degrees. It's going to be x equal to 60 degrees plus 360 degrees times k, where k is an integer. Right, in quadrant 4, it's going to be 360 degrees minus reference angle. So x equal to 360 degrees minus reference angle, then plus 360 degrees times k, where k is an integer. So it's x equal to 360 degrees minus 60 degrees plus 360 degrees times k, where k is an integer. Right, so x equal to 300 degrees plus 360 degrees times k, where k is an integer. So this is the general solution. So we have these 4. We have 1, 2, and then 3, and then 4. We have all these. Okay, right, you have to write all the 4 of them.